Let's talk about the synthesis of amines now. It's not a whole lot, but we still have some new synthesis to do here. So most of the reactions that we will do to make amines actually are reduction reactions. So that kind of makes it easy and in a way to remember. Then you also have to kind of keep in mind as we are going through all the synthesis is that there are certain ways you can make primary or secondary or tertiary amines. Okay, some syntheses are really good only for primary, whereas some are good for all three of them. Okay, so just keep that in mind as we go through all the synthesis. So first of all, substitution reaction. Okay, so when you're doing substitution reaction, just like a normal, so here is ammonia, here is your substrate. So with the substrate, what happens is that the ammonia will attack the carbon that's attached to the leaving group, right, as normal. So you end up getting an amine. The problem here is that you can end up getting multiple substitutions, okay, and that's what I've shown over here. So you can go all the way from primary to secondary to tertiary and then quaternary amine. So each of the amines that is synthesized, that amine now becomes a good nucleophile, and that nucleophile will then start reacting with the substrate. Okay, and then you start getting more and more reactions until you get to quaternary amine. Okay, and all the R groups are going to be the same here because everything is happening in the same thing. So that's what ends up happening, okay, with this kind of a reaction. So here is another example I've given you. I didn't go all the way to quaternary, but you can go all the way to quaternary with this. Okay, so here is one example. Going all the way to quaternary. All right, so this is something you have to be careful of, which means what? I mean, it's great if you wanted to make a quaternary amine, but definitely not great if you want to make a primary or a secondary amine. Okay, so it's not that it's a completely useless synthesis. It's just that you choose what you want to use for when you want to use it. So here is another one. Now this one is using an azide. So this is also substitution reaction. This is also SN2, but in this case, our nucleophile is going to be this compound, which is an azide. Okay, this is an ion, and you find it in sodium azide or potassium azide. So because the azide is an anion. Okay, so it has to have a counter ion, which is sodium here, for example. So here, when you take an azide, treat that with a substrate, you end up getting an azide as your product, but that azide is not isolated, and then you go on straight to reduce that using LaH, lithium aluminum hydride, and you get an amine. Okay, note this is a primary amine. Okay, so this is only for making primary amines. So here is another example. Now we've done epoxides before, and I might have written this reaction before, but if not, here it is again. So, you know, if you have an epoxide, you can use that azide to open up the epoxide, and then you still can get an amine over here. Okay, primary amine, no matter whether it's in a ring form or in straight chains. Okay, only primary amines. Gabriel synthesis is specifically for primary amines and primary amines only. Okay, now azides can be used for that too, right, as I just said, but azide can have other issues, like do you want to work with a compound that might be a little dangerous to work with, right? Maybe not. So you come to Gabriel. Okay, the Gabriel's reagent is phthalimide reagent, which is this. So now you can take any substrate and treat that with the phthalimide, and you end up getting a primary amine. How simple is that, right? So nice, simple, easy, and safe way to make a primary amine. Now this one that we're going to do, which is reductive amination, this is going to be a big one, okay? Because you can take almost any kind of aldehyde or a ketone, and whatever amines or oximes you have made back then, you can treat all of them with lithium aluminum hydride or any reducing agent, and you can get an amine. Okay, so don't be confused over here, just keep following my lead. So here, if you have a carbonyl, which is here I've taken an aldehyde, you can take a ketone also. Okay, so any kind of carbonyl and ammonia. So this is the amine that you get. Remember, we did amines back then. So now if you take this amine and you reduce it, you can get an amine. Okay, so that's how it works. That's if you take ammonia. All right, so here is an example of that. Now, if you take a carbonyl and a primary amine, okay, so here we have a primary amine reacting with a carbonyl to give an imine. So once you do this, then you reduce it and now you get a secondary amine. Okay, so you can either make a primary amine or secondary amine depending on what kind of amine you start with. So here is secondary, all right, that you end up forming. So that depends on what kind of starting material you're starting with. But it's an easy way to make an amine. Okay, so now you have choices because now you can make either primary amine or secondary. So until now, like the azide gave us only primary, Gabriel gave us only primary, but now you have a way of making secondary amine also. Okay, now here look, I've given you a different reagent, okay, for reduction. So here I wrote LaH, here I wrote ranitidine. In the end, I'm going to give you all the reducing agents you can use here, but you can use either lithium aluminum hydride or you can use ranitidine, and we're going to have some more, okay, as we go on. So here we have, if you were treating an alkyl, an aldehyde or a ketone with a secondary amine. So remember, with a secondary amine, you end up forming an enamine. Okay, an enamine is when you have, let me write that, an enamine is when you have an double bond and this, okay, and the amine group in there. Imine was when you had the double bonded nitrogen, okay, on there. An R group, whether the R is hydrogen or an alkyl group, that's different, okay, but this would be an imine. And an enamine is when you have the double bond in there. So, you know, this also happens with aldehydes and ketones. So if you have an enamine, that's fine. You can also work with secondary amines. You'll form an enamine, which then can be reduced. Okay, so now look, see what you have. You have a tertiary amine now, okay, in this case. So this is even more better, I don't know, okay, not good English, but this is, you know, it gives you a variety of amines that you can make using reductive amination. Okay, so here is an example of that. I took a ketone here with a secondary amine, and now the final product that you end up getting is going to be a tertiary amine. Okay, so it's a nice way of making different kinds of amines that you want to. You can take any other kind of derivatives also from aldehydes and ketones, the oximes and all that, and you can reduce them as well. Okay, so I have 3 nitrogen functional groups here: nitriles, oximes, and amides. So here is an oxime, here is a nitrile, and then here is an amide. Okay, so here we're taking 3 different kinds of functional groups. So if you have an oxime, this is an example. Of course, the left one is the generic reaction. So here, if you take an oxime, reduce it, you get a primary amine. You take a nitrile. We've done this in carboxylic acids, and you reduce that, you get a primary amine. And then over here, if you had an amide, depending on what you have on the nitrogen, okay, I just took this amide where you have, you know, 2 groups on the nitrogen. Here is the amide, right? So if you take an amide that's all substituted and you reduce that, then you end up getting a tertiary amine. Okay, so you can have a secondary amine also using an amide, again, depending on what kind of groups you have on the nitrogen. So I can't give you absolutely all examples, but you see what I'm trying to do here. Okay, is just give you a variety of reactions that you can do. Now these 2 here, the first 2, this will give you only primary amines, as you can see, because, you know, there is not much variation there. And nitriles will also give you only primary, but this one can give you secondary, or it can also give you tertiary, okay, depending on what kind of R groups you have. Do you have H and H? Then in that case, you have only 1 carbon, right? So that would be a primary. If you have R group here and H over here, that would be secondary. If you have R and R, like here, this would be a tertiary. Okay, so depending on what kind of groups you have around nitrogen, with amides, you can actually get primary, secondary, or tertiary kind of amines. Okay, so it depends. Maybe I'll, you know, add a slide later on and show you all the different reductions, but this is, I mean, it's pretty self-explanatory, I think. Okay, and then we have also done this reaction where we have reduction of the nitro group. So you've done this back in aromatic chemistry, and it is not really a benzene ring reaction. It's actually a nitro group reaction, but this is how we did this, right? So benzene was nitrated, and then after the nitration, then you can reduce the nitro group. You can either use lithium aluminum hydride, or you can use a metal with an acid, okay? And both of them will give you an amine group. Again, this is only a primary amine, so you can only make aniline, okay, using this. Now, I've given all sorts of different kinds of reducing agents over here, okay? So you kind of have to note that in a lot of places you can use different kinds of reducing agents. So here, can you use ranitidine? You can use it, but do you want to use it? That's the thing. LAH is easy enough to use, So if you don't have any other group that can be reduced like carboxyl or ketone, then just use LAH, no big deal. But if you did have a carboxylic group or an aldehyde or a ketone, then you may want to use the metal with HCl. Okay, so that way you don't reduce the other group, you only reduce the nitro group, if that's what you want. And then finally, I think this is the last synthesis for amines. This is called Hofmann rearrangement. Now, Hofmann rearrangement is done only on primary amides, and it can only give you primary amines. That's it, okay? And a primary amide meaning that you don't have anything on the nitrogen. You only have the two hydrogens on there. So no alkyl groups. If you have any alkyl groups on the nitrogen, this reaction is not going to work. But otherwise, it's a super efficient reaction. So you take a primary amide, treat it with bromine and sodium hydroxide, and then you end up getting a primary amine. So here is an example of that, and see what happened here. Okay, and I want you to note this because it's a very interesting kind of a reaction. Okay, so here is the 1, 2, 3, 4. So you have 4 carbons in a chain. But look at this, 1, 2, 3. So which means this carbon, vamos, is just gone. How is it gone? It's actually gone as a carbonate. Okay, so that's how it goes away. So which means you're short 1 carbon, okay, when you do Hofmann rearrangement. So I've given you the mechanism, and you can go over the mechanism yourself if you want to. I never ask for it, but it's kind of nice to see how you can actually get rid of a carbon, in there. So I've colored it also here, so you can see how the carbon is being, removed. Okay, the whole carbon is being removed. So go over it if you want to. And I think that's it, right? So here are all the reducing agents you can use. Now you can write yourself as to which one you want to use where. So for example, this one is really good for nitro groups, okay? Now, when you do hydrogenation, you want to be really careful, okay, with that, because hydrogenation can reduce a lot of things, okay? And hydrogenation has to be done usually under some kind of a pressure. So unless you're reducing alkenes and alkynes, which are easy to reduce, but if you have other functional groups that you're trying to reduce, like carbonyl or nitro or anything else, then you need high pressure. So you don't really want to use hydrogenation if possible. Ranitidine is the better choice, okay, for doing simple hydrogenations and reductions. This is not as, I wouldn't say potent, but this is not as strong as hydrogenation, okay? So this is a little easier to do. But if all else fails, then you can use any of these reagents, okay, for your reductions. And I can give you any one of these also. The only thing you have to be careful of is if I'm using this reagent, am I going to be reducing some other functional group that's in there? Okay, so you have to be careful for that. Other than that, all these reagents are just reducing agents and work just fine. That's it, all reductions here, okay?